Okay, let's dive into something really specific today. Our mission is to dissect one single piece of gear, the PureLink PI4000-100. It's a DVI cable, a 10-meter one, and it costs $150.99. Now, why on earth are we analyzing a cable? Because in professional installs, reliability over that kind of distance is, well, it's everything. You can't have signals dropping out. We want to know what engineering details justify that price.
It's a great question. And you're looking at a DVI single-link cable designed for rock-solid connections. Think a computer to a big industrial monitor.
And 10 meters, that's almost 33 feet.
Exactly. And maintaining a clean digital signal over that kind of span, that's what you're paying for.
Okay, so let's unpack that. Since it is a DVI single link, what's the guaranteed performance ceiling? What can this $150 cable actually handle?
Right. So the certified maximum resolution is 1920 by 1200.
WXGA.
That's the one, WXGA.
Yeah.
And that capability is tied to its bandwidth, which maxes out at 165 megahertz. That gives you a transfer rate of about 3.72 gigabits per second. That's the guaranteed performance for the full 10 meters.
I see.
And, for professional use, it supports all the standards you'd expect. HDCP for copy protections.
Of course.
And CEC, which lets devices control each other, plus all the usuals like Full HD, HD Ready, and so on.
That makes sense for just, getting it integrated. But let's get into the physical construction. What justifies that cost? You mentioned the conductors are high-purity, tinned-plated OFC copper. Now, OFC is oxygen-free copper. I get that. But why the tin plating?
That's where the details really start to matter. The OFC copper gives you maximum conductivity, but the tin plating is for longevity.
How so?
It makes soldering the wires to the contacts, which are 24-karat gold-plated, by the way, much easier and cleaner. And it also creates this immediate barrier against oxidation right where the copper meets the connector pin.
So the gold protects the outside from corrosion, and the tin protects the inside connection point. That's a great insight. Now, what about this TotalWire technology? Is that just marketing, or is it about the shielding?
It's PureLink's brand name for their whole rigorous construction, but yes, it's mostly about the shielding. This is the real secret sauce for getting that 3.72 gigabits rate over 10 meters. It's a robust 3-layer shield.
3 layers.
3. 2 separate layers of aluminum foil, both 100% sealed, and then an outer braid that is also 100% sealed. Without that triple barrier, noise would just destroy the signal over that distance.
So, putting this all together for the buyer, we did notice something a little odd in the feature list. The description mentions high-speed HDMI for 3D and resolutions up to 4K, and an Ethernet channel. But this is a DVI cable. What is?
Yeah, that's an important point about product line marketing. This specific cable, the PI4000-100, is a DVI D18 plus 1 pin. Its specs absolutely limited to 1920 by 1200.
Okay.
So those other features, the 4K and Ethernet, that refers to the broader PureInstall series of cables, which includes HDMI versions.
So they're advertising the family features, not the individual one.
Exactly. This cable does its one job perfectly, and that guarantee is backed by a 25-year warranty. And, this is key for a certain market, it's TAA compliant.
The Trade Agreements Act.
Right. Which means it can be installed in U.S. government and military facilities. That's a huge market for professional AV.
A successful deep dive, then. We went from a simple price tag to understanding you're buying 3 layers of sealed shielding just to make sure a WXGA signal never drops.
And that's the final takeaway for you, the learner. In pro-grade gear, the expense often comes from the rugged construction needed to guarantee performance over distance, not just raw speed. It's the price of reliability. And here's something to chew on. If this 10-meter cable needs triple shielding just to guarantee about 3.7 gigabits per second, what radical and probably very expensive engineering must be happening inside cables to push stable, certified 4K or even 8K signals over 50 or 100 meters?